Here we have the series 4 plus cosine of n divided by n squared, and we want to use the direct comparison test to show that this infinite series converges. And once again, to use the direct comparison test, we have to come up with a series b sub n, and we have to show two things: that the series a sub n, which is the given series, is less than or equal to the series b sub n, and we also need to show that the series b sub n converges. And so we let a sub n be the given sequence here, and then we can let b sub n be something similar. In this case, notice that cosine 4 plus cosine of n cosine of anything of any angle is always between -1 and 1. And so the cosine of any of n will always be less than or equal to 1. And therefore 4 plus cosine of n will be less than or equal to 5. So we can let b sub n be 5 over over n squared. And so now we can say that this is less than or equal to b sub n. And hence this, the given series will be less than or equal to this series, to the series b sub n. And so we have shown the first part, and now we also need to show that the series b sub n converges. But this series is the same as this. This is a phi, which is a multiplication constant phi, so we can move it and place it in front of the summation notation. And then this series right here is a p series. With p equal to 2. And recall that for p-series test, if p is greater than 1, then series converges. And therefore, this series converges. And so by direct comparison test, this series right here converges also. So once again, to use the direct comparison test, we have to show two things. Series A sub n is less than or equal to series B sub n, and we also have to show that the series B sub n converges. And again, the logic behind the direct comparison test is this. This series is always greater than, because this series, this quantity right here is always going to be positive or zero. In this case, wouldn't be zero. It's always going to be greater than zero. And then we have shown that this series converges, meaning it's less than is equal to some real positive, real finite number. And so we've shown this series between 0 and k. And since it's a positive series, it's monotonic, and therefore it also converges. So that's the logic behind the direct comparison test.